Hello friends, how are you? All of you are doing fine, I hope so. Welcome to all of you once again on your channel, that is on JEE Physics Maniac. So here I come up with another question, not extremely difficult, a little bit tricky, a little bit different, and it can be a good case study for JEE Advanced 2021. So let's proceed without wasting much time. So here you can see that the statement of the question is giving a rocket is projected vertically upward with an initial velocity v0. Now during ascent, matter in form of exhaust is continually ejected vertically downward direction with a constant velocity u. If the weight of the rocket at any time t is given as m into 1 plus e to the power minus kt, so it's given an exponential function, then they're asking find the maximum height attained by the rocket, neglect k square and higher order terms. So I request all of you, before proceeding to the final answer, you pause the screen and try on your own. In case if you are not able to get it, then only you go forward to look the solution. Anyway, so what I'm doing here, so I'm just trying to calculate the mass of the rocket as a function of time. Since the weight is given, so mass is equal to, we can write this simply Wt divided by g. So this must be g here. So I can safely write this is Wt by g. So m function of time is coming m by g into 1 plus e to the power minus kt. So in the next step, what I'm doing, I'm simply expanding this exponential term. So if I expand this exponential term over here, it comes m by g into 1 plus, now 1 minus kt plus k square t square by 2 factorial minus, it continues like that. As the instruction is given in the question that we have to ignore k square and higher order terms, so only we will consider up to this much, okay, and we will ignore the k square term. So mt is coming like this, mt is m by g into 2 minus kt after approximation. Fine, okay. Now from here, as you can see, I can calculate the rate at which momentum is imparted, correct? So we know that here in this case, in case of rocket motion, and this momentum is basically given as v dm dt. Now here in this case, this v is u as mentioned in the question. As you can see here in this question, they have said that it is vertically ejected with constant speed u. Fine. So that's why I am writing v dm dt. Minus sign is only for the ejection that it is being continued. Okay. So after derivation, it comes to be km u divided by g from the calculation. Now I can write that the reaction, because of this the rocket will get some thrust reaction, so that reaction is km u by g, right? So it has its own weight and this is the reaction it is getting. So what is the total force? Total force will become downward force km u by, reaction is km u by g minus of weight is this much, right? So if you can just have a quick look, this is the rocket. So because of the ejection, it is getting a reaction in that direction, that is kmu by g, this quantity, and at the same time it has a downward weight, that is simply m into g. All right, fine. Chalo. So this is the net force acting on the rocket, that is equal to mass into acceleration. It's a simple representation. So from there I calculate a is coming to be this quantity here, that is ku by 2 kt minus of g. Fine. Again, what I'm going to do, I'm simply going to take ku by 2 common. So the bracket term downward, it will come here. So it will be to the power minus 1 and it becomes 1 minus kt to the power minus 1 minus of g. So if I do binomial expansion again, it will become ku by 2 into 1 plus, this minus 1 will be multiplied here. So it will become 1 plus kt by 2 minus g. If you multiply again, you see this term, when it multiplies with this term, there is a k square term produced. Again, we have to ignore that term. So after final ignoring the result here, final acceleration we get simply ku by 2 minus of g. So this is the constant value. As you can see, it's a constant acceleration, right? Okay. And we know that if initial velocity is given, maximum height that can be achieved by the rocket is given where h max equal to ui square by 2 into ay is a common form. It's a general form which you can apply for projectile motion also, right? So there h max equal to ui square by 2 ay, ui square is given as v0 square, and we have calculated the value of ay, that is equal to this one. So the final answer becomes v0 square by 2g into 1 plus of ku by 2g, right? So it's an interesting problem. It's a quality question. I mean, not extremely difficult, but it's a little bit different. So I hope you have enjoyed. If you have enjoyed this video, please share, subscribe, and hit the like button. That's the only thing that I can get from you. Thank you.